Hey, John Gilroy here. Today, we're going to talk about fast content delivery. Hit the music, Manny. Welcome to the Federal Tech Podcast, the podcast that connects you to federal technology leaders. My name is John Gilroy, and I'll be your moderator in the virtual studio. Today is Omeed Nosarti. He's the field CTO of a company called Fastly, F-A-S-T-L-Y. Don't need to spell. It's pretty easy. How, Omeed?
You got it, John. That's how it is.
Content delivered quickly. It's all about content. Even the federal government has to provide content for, hey, we got a tax deadline coming up. You got to provide content for that. What about emergency situations? You got to present content for that. So I think it's important to talk about speeding up delivery of content for the federal government. And because we're in the Washington, D.C. area, we have a mandate to talk about security as well. So maybe you can give us a little nutshell origin story for Fastly, and then we'll jump into the federal questions.
I will give you the nutshell origin story of Fastly, and then also in support of what you said for the federal government. Increasingly, I think the government has realized that folks are at home consuming federal services. User experience matters. Obviously, the content showing up to our virtual doorsteps in the best way possible matters. The government's doing a good job of keeping up with how folks want to engage. So I think you're on the money. So Fastly, we were born at a time where there were a bunch of other CDNs. Akamai was around and had been around since 1999. At the time, there were folks like Edgecast, Highwinds, CDN 77, Cachefly. There were a bunch of CDNs. The reason that Fastly was born was actually out of frustration with using the other CDN solutions. So our founders were actually users of CDN when they were running Wikia. And they were frustrated with the fact that CDNs felt like a black box. They were frustrated by the fact that CDNs did not invalidate content from the caches very quickly. And they were maybe less than super pleasant people to work with. And so their brilliance paired with their frustration had them building their own CDN as an internal point solution to Wikia. They built the CDN to be super responsive. They built it to be super fast and reliable. And they also built it because they were using it as a tool. They built it as a tool that was easy to engage with. What happened very shortly thereafter is that folks found out that Artur Bergman, Simon Wistow, Tyler McMullen, a couple of others were the founders, had built this really cool network, and they wanted to try it out. And so their friends tried it out and said, you know what, you could totally spin this out and turn it into a company all on its own. And that's what happened, and that was the birth of Fastly.
During those early years, you're such a young guy, I'm an old guy. In those early years, I remember there was a denial of service attack, a DOS attack. Whoa. Yeah. Then they went, hey, let's take it up another level. It's going to be a distributed denial of DDoS. And I think CDNs were instrumental in trying to respond to that back then and even today too, aren't they?
They are. So what a CDN does very effectively is take a large volume of requests, and if they're healthy requests, good requests, it pairs them down through request collapsing so that the origin only sees a few or one in our case, which is a major differentiator of Fastly. But they also have tons of flexible capacity. So in the case of a DDoS, if you're getting a 350 gigabit per second or a terabit per second DDoS attack, the CDN has spare capacity to respond to those requests and keep the origins healthy. The world has changed quite a bit. DDoS attackers are no longer affecting very large volumetric attacks infrequently. What they are starting to do is affect small volume DDoS attacks over time to try to kind of pen test and understand where are the gaps in security that I can exploit later on. So the game has changed a little bit, but yeah, DDoS attacks are very much still in play.
I tell listeners they know that my favorite podcast is what's called Feds at the Edge. And from the Washington, D.C. perspective, there's feds all over the world in outer space. I mean, there's all kinds of edge computing going on. People are looking at compute at the edge and doing all kinds of things at the edge. But this might be where the DDoS attacks may be good targets, aren't they?
Yeah, I think anywhere there is low connectivity, a DDoS attack is going to work really well. But again, it's difficult to find entities that are not fronted by a very high capacity vendor. So it's those low-level DDoS attacks that are, in my opinion, a lot scarier at this point. They don't melt services down. They don't melt systems down as readily, but they are very effective in finding potential attack surfaces for nefarious actors.
Washington, D.C., of course, loaded with acronyms and abbreviations, everything else, and a real popular one now is ZTA, Zero Trust Architecture. So how does your company work with ZTA, especially in federal applications?
So we actually don't provide ZTNA or SASE services. We leave that to folks that we believe are experts in that:
Ah,
Netscope, Zscaler, Palo Alto Networks. We do have some competitor CDNs that say they have ZTNA SASE services, and certainly for some use cases that can make sense. But for most enterprise level use cases on ZTNA and SASE, we recommend that folks look at Zscaler, Netscope, and the folks that have kind of grown up doing it.
well, that's a fair answer. I'd rather have that than, yeah, we do everything, but now people know exactly where you fit in this game. And I want to go back to this edge thing. Now, you got speeding up services, you got edge compute, you got security. And so how does your platform help with optimizing speed in all this complex environment?
So for us, it starts at the ground level, which I know sounds cliche, but is very much true. So when we purchase servers or we configure those servers, we build them to be optimized for very fast cache retrieval and cache delivery. We also don't have, as an example, any routers in our network. We use code, which is one less thing that can go wrong and one less hop in the network. So we've written a lot of proprietary code and gone as deep as cracked the Linux kernel for our operating system, done a bunch of TCP tweaks at the lowest level possible. I mean, I'll give you another example of how low it goes. When we get new shipments of new generations of chipset, we burn them in and we try to find where they're most efficient. So we run them at like 99%, then we run them at 75%, and we try to find like for this generation of chips, like what load should we run them at that gets us to a sweet spot of longevity and performance. And it's very common for us to go back to Intel or AMD and say, hey, we think we found a firmware opportunity for you. Would you like to engage with us to do a firmware update? And it is also not uncommon for us to get to the end of the budget cycle for AMD or Intel, where they're like, we got no more money to spend on firmware on this generation, but we'll talk to you on the next generation, which for me is a huge source of pride. But how we build latency, reliability, and ultimately efficiency into our system for our customers starts all the way down at the code and the firmware level with the available hardware that we have. From there, so server architecture is, speaking at a high level, all SSDs, tons of RAM, so that we can do fast lookup. We also optimize the lookup tables on the SSDs to optimize for longevity. So instead of looking across every cell of the SSD to find the content, we divide the cell into columns with metadata on top of the columns. And if we find the metadata for the content, we go down that column instead of going all the way across everything. And that gives us a lot better SSD life and faster performance. So server architecture is very important for us. Very high cache density is what we're trying to achieve. And then our network architecture is also very different. So if you wind back the clock to 1999 when Akamai set their network up, they did a great job. Their goal was to connect a bunch of disparate networks together. Like you couldn't get from here to Hong Kong and back using one length of transit, but now you can. So Akamai having 4,600 servers in the world, or another example, Cloudflare having like 360 some odd servers in the world, all of those local points of presence are potentially entities that can come back and ask the origin for an answer. So what we try to do is reduce the number of POPs as much as possible while maintaining a close geographical connection to all the end users that would benefit from the use of that POP. So we have like 96 POPs in the world, but we also have larger edge capacity than our competitors. What this means for our customers is cache hit ratio. So there's a bunch of other really cool stuff that we do on top, and I'll call those features. A lot of them living in VCL, which is varnished configuration language. It's how our customers tell us how to cache deliver their content and how to do what they want us to do. Think of it as caching instruction set. We reveal that to our customers to do their own tooling if they wish. But where it starts is server architecture, network architecture, and all the proprietary code that we've deployed.
Whenever I have discussions about CDNs, inevitably web application firewalls come up. And some people will say, well, we review signature-based attacks. And traditionally, what's happening in the last 4 or 5 years is they're moving away from that into something more dynamic, maybe behavior. I imagine that your next generation WAFs are making that transition as well. Is that right?
Mm-hmm. So our WAF, we benefit from a couple of different things on the WAF side. So first, most WAFs, if not all WAFs that are not Fastly, use regular expression matching, keyword matching. So if the keyword shows up in the request, block that content. What that does for our customers is it's a bunch of false positives usually, and then they'll set up the WAF, and for the life of the WAF, they're managing false positives out. It's called policy management, and it's a not, I don't want to call it a burden, but it's a major thing that cybersecurity professionals that are ICs are working on. The way that we approached it, so actually, Signal Sciences is the company that we acquired and then bolted on to run inside of Fastly distributed, which is different from our competitors, was born of very much the same primordial soup as Fastly. It was an internal point solution built out at Etsy because Etsy, online retailer, does not want false positives. That's a missed
Yep.
transaction. That's missed revenue. So they built proprietary code called Smart Parse, which does lexical analysis of the request instead of just doing keyword matching. And then on top of that, for day zero CVEs or anything very specific that our customers want to set up, we give them the ability to build their own regex rules. Absolutely, we make that really easy for them. But it starts with Smart Parse. So the analogy I like to draw is instead of building a giant wall and then punching all the bricks out to make sure that your healthy traffic can get through, build a wall that is completely complementary to your unique traffic profile and the ecosystem sitting behind it and make it very tunable in real time. So that's our WAF technology. And yeah, a proprietary technology, Smart Parse, is what makes it run and reduces false positives by so much. So actually, a little data point for you. We had Forrester do a report on us, talk to our customers and say, what was the ROI of moving to Fastly on both the infrastructure side and on the security side? And I believe the security ROI was like 236%. I mean, I see
Hmm.
50% and I get excited, but 236%, I was like, oh my gosh. But the reason is we're enabling revenue where otherwise it was false positives. On the infrastructure side, I think it's because of the efficiency of caching, the better latency for more revenue and all that stuff. And the infrastructure ROI was, I think, 180 something percent, which is, again, we were very happy to see those results.
Taking notes here, and I put down. I haven't, written down the word regedit in so long. I don't know how many listeners actually have ever edited, regedit. I mean, this talk about DOS and DOS. This is really an old school application, but really it gets down to the nitty gritty of some of the things we're talking about, and kind of makes me smile when oh yeah, I remember trying to do that years ago. That was really a challenge.
Yeah.
I'm still doing it today, well, at advanced state.
The
Yeah.
the landscape of the internet has not appreciably changed. Like when Akamai built out their network, okay, network topology was a thing that was very different than it is today. And for sure, we see new dark fiber getting lit all the
Yeah.
time. But HTTP, TCP, the major protocols and standards, like those are still very much in play for almost everybody. We see some folks working with UDP,
Wow.
WebSockets, but for the most part, it's still
Really,
HTTP,
UDP.
TCP.
Wow. Good.
Yeah.
Good. Let's talk about olden days. When I was in college, young man. No, I took a course in tennis, and the guy said, "Look, you got to hit him where they're not." Oh, okay. And so apply it to today. So what people are doing is going, "Oh, this firewall's pretty good. The CDN's working. This is working. That's
Yeah.
working. Let's go after the APIs, man." Oh, well, no one worries about those. And so we see APIs being attacked. And in the last 6 months, I'm sure if you did a Google trend and looked at API, I've heard figures of 900% increase in API attacks in the last 6, 8 months.
Mhm.
And so that's the malicious actors are going where they're not. So does your company play anything for protecting federal API from these attacks?
Absolutely. So we provide, again, APIs or HTTP. And I would say that the rise in API attacks is both because attackers are trying to find new sneaky ways to hit people, but also because there are just a lot more APIs out there than there used to be.
Yes. Yeah.
So the attack surface is much larger, and APIs are carrying credit card data and like trip itineraries and other PII, so they become really juicy targets for folks. I think that's probably the primary reason we've seen such a rise. But yes, absolutely. So in addition to providing very awesome HTTP request-based mitigation, which is what an API is, we also provide API protection. The things that I think make an API security provider an API security provider are like the adornments or the ergonomics features, and those are API schema enforcement as well as API discovery. API schema
That's the
enforcement.
point.
Yeah, that's what makes it a full-fledged API security play. So schema enforcement just makes sure that your APIs, the format of them, you're not leaving any gaps, you're not leaving any threat vectors out there. The other is API discovery, and this is particularly important for organizations of tenure because they've been setting up APIs for a long time,
Right.
and they
I'm trying
haven't
to.
been managing them.
I'm trying to control, try to develop a new phrase called shadow API, where maybe some software developer puts together and doesn't tell anyone. And all of a sudden, Omeed walks in and goes, "What's that?" And I go, "Well, I didn't know. The
For
guy
a
here
long
before me did
time,
that."
Dude, for a long time, I mean, I can see it kind of reverse engineer. I can kind of see how it went for each of
Yeah.
the customer organizations we work with. But it's as though they were setting up shadow APIs as the just, in the sun APIs. They were just setting up APIs. There wasn't really a concept in the early days of managing the APIs, making sure that you know what the workloads are going across the APIs, and having a clear accounting of which machines are talking to which machine. I mean,
Yeah.
people just set stuff up, and so again, an analogy, we walk into a customer environment and they say, we need API discovery. And I say, well, give me some examples of where your APIs are going. And it literally looks like a bowl of spaghetti. Like it's just,
I know.
crisscrossed all over the place. It's really difficult to get your hands on. But yeah, API discovery with us is auto magical. You run traffic through Fastly. We identify all the endpoints and give a clear accounting. Here are all your APIs. And usually customers are pretty surprised. They're like, oh, I didn't realize
Yeah.
we had that API set up. Okay.
We started off talking about content delivery networks and content and attacks and traffic. Let's go back to that. Maybe the phrase that pays, of course, is AI. So how are you folks using AI to mitigate some of these, I guess, traffic management attacks? Is that what it is? Or like filtering traffic? So are you using that? And I know that the malicious actors are. So how are you guys countering that?
AI is a really important tool, and it's really important to understand what it can and cannot at this point do. So, a lot of the WAF providers out there are talking about AI and machine learning to fuel the actions that AI will take. And I'm happy to be wrong, but in my experience with the market, the machine learning step takes so long that by the time you implement the rule via AI that has been distilled by machine learning, the rule is no longer it's obsolete. It takes a period of time, and it depends on the size of the data set, and depends on the amount of resources you have for the machine learning. But if you take a regular normal day's amount of traffic and feed it into an ML engine, usually that takes a couple of days to crunch the numbers and say,
Yeah.
okay, this is what we recommend that you do, and you still need to validate that. Like, we're not sure, we just think these are good areas for you to investigate. But by the time the ML engine has run through all that stuff, like that, that attack vector may be obsolete, or there may be an actual hot fix for it. So what we tell customers is, in order for you to be really responsive to what you're seeing in your network, if and when we get to the point where AI and ML are fast enough to render responses and recommendations quickly, we're on board. But we also have to be in a place where we're confident in the recommendations that it's making. We're not quite there yet, at least from Fastly's perspective. What we recommend to our customers is have very granular understanding of your traffic in real time, which we provide, which is a differentiator of ours, and then utilize our adornment of the traffic profile to understand where the threat vectors might lie. So as an example, we provide this thing called Network Learning Exchange. So we deliver traffic for the largest brands on earth. Google, Apple uses us. Almost all the big streamers use us as primary. Most of the big e-commerce players use us. Almost every publisher uses us. So we see a lot of threat vectors every single minute. When we see a threat vector and it's identified as a threat, we throw that into a database that all of our other customers get to benefit from. You don't know which customer was hit by the attack, but you know the profile of the attack. And we clearly annotate that in our control panel. If folks are using us using API, which a lot of our more sophisticated customers do, you see it that way. But you basically benefit from all the threats that have been seen by all of our other customers all around the world, and you see it in real time, which is really cool.
Well, Mead, final question here, and this may surprise you. When companies deal with the federal government, federal people give a lot of respect to commercial success. And a lot of times in commercial success, they talk about ROI. Hey, Omeed, show me the ROI on this, And so just give me an example of return on investment for a commercial company, then maybe my govies can go, yeah. So give me a ROI example so our govies can write it down and go, see if it applies to us.
So we see ROI gains in terms of hard costs on infrastructure, and we see ROI gains certainly in terms of human capital costs. I'll give you an example of each. So when Forrester came out with a report that said Fastly provides 180%, it's 180 something, but 180% ROI on switching to Fastly for infrastructure, that's because of two things, in my opinion, probably more, but mainly two. One, the way that we do request collapsing and the architecture of our network means that for any new piece of content or change to an existing piece of content, you're only getting one request at your origin. We don't hammer your origin and then you have to pay the egress fees sending data out to all of those edge nodes or to the small number of mid-tier nodes, which our competitors provide. You only have to send a response to one node, which you get to provision the location of, and then that propagates the content out to all of our edge nodes all around the world. And every single edge node in the world can act as that single node that talks to your origin. So one requested origin ever for a change in a content or a new piece of content. So that's a huge ROI gain. The other piece of that is because of the latency metrics that we provide to our customers. I mean, it's in the name and it's kind of, again, cliche, but we're super fast. They start to see more engagement from their customers as a result. So for Fed, I think it's a little bit different because if I want to go to the IRS website, that's the only place I can get the content. If it's slow, I'll wait. But for our e-commerce customers and for our publishers and for the streaming customers, like there are a bunch of other places that an end user can go to get that same content. So the competition is fierce to keep those eyeballs there. Marketing gets them there. Really good performance and user experience keeps them there. And then on the human capital side, because of the fact that we're entire API enabled, you don't have to basically hire teams of people to sit between your origin changes and your infrastructure changes on the CDN side to make sure that everything agrees with one another. There's no coordination that has to happen. You can use API calls to tell Origin to tell Fastly what to do and just kind of take people out and have them work on new experiments or work on building the next wheel or whatever it may be. There are a bunch of other examples. Those are the big ones. And then on the security side, I mentioned it earlier, but instead of doing regex matching and keyword matching, which yields a lot of false positives, we use Smart Parse. So we're only caching requests that by analysis or by lexical analysis, we deem threatening or a problem. And so again, what I advocate for with our customers is don't build a giant wall and then punch out the bricks. Build the wall in the way that makes sense for you. And that enables a lot more revenue. So for Fed, again, if I'm going to go to IRS, that's the only place I can go. If IRS throws up a false positive, I'm going to phone a representative or I'm going to wait until, the solution is implemented. For our commercial customers, I mean, we're talking the difference of millions of dollars per month or even week, depending on their volume. We have e-commerce providers that are that large as customers where false positives mean we just lost out on a bunch of money and more so over time. So yeah, primarily for security, the ROI comes from proprietary technology for us.
I mean, you may be surprised that some agencies are very interested in speed, so may shock you. I know a couple of them, but hey, we're not going to go there. We have to finish up this interview here. You have been listening to the Federal Tech Podcast with John Gilroy. I'd like to thank my guest, Omeed Nosarti. He's Field CTO at Fastly, and I'll put the link to the Fastly website right in the show notes. Thanks, Omeed.
Thank you, John. That was awesome. Cheers.